Welcome everyone to this beautiful March day in Albuquerque, New Mexico. We're here at the Wheels Museum. We have a speaker today, Donatella DeMonzo, talking about Route 66. We have a music presentation at noon and a birthday party. But the most important thing today, and for many, many days, is the fact that I'm thrilled to have Terry Davis with us here today. He's a longtime Wheels volunteer, and he's a wonderful friend and a wonderful volunteer, but I never realized how important he was to the railroad development of the world, because he's very humble and he doesn't brag about things that he's done. But when I found out, I said, oh, we have to have you on a podcast. So the first thing I want to ask you, Terry, is I know you have a very prominent educational background. Tell us a little bit about that.
Well, I went to California State College, but not in California. You probably don't know that, but
That I didn't know.
But there is a school in California, Pennsylvania, southeast of Pittsburgh.
Okay.
And I got my BS in math and computer science there. And following that, I started my master's work at Penn State and went there for one semester and then transferred to Pitt, University of Pittsburgh. And I got a teaching assistantship at both places where I taught first level computer science to the undergraduates. And that's about my education.
Okay, good. And then you got a job. So that's what we want to hear about, how you revolutionized the railroad with microprocessors, and you did things that really did, not only in America, but in China, change the way the railroad works. So please tell us about that story.
Well, the company was Union Switch and Signal, and they were based in Pittsburgh. And at the time I was getting my master's degree completed, they were putting together a team of young engineers who knew all about microprocessors at the time. And they were going to, the goal was to replace the relay systems. And at the time, the railroad was controlled by these giant relay systems, and like there'd be a piece in the tower where the commands would be executed to pull levers and make the switches move and make the signals go green. And that would be connected to the wayside. You've probably seen along the tracks these metal gray cases that contain the other side of this equipment. So the project was to leave the fail-safe relays in the field alone, not to bother those. Those are too complicated at the beginning. The goal was to replace the field equipment and the office equipment and the communications lines.
Okay.
So this was all before the IBM PC came into being. So the boards needed to be created, built. Computer boards needed to be made from scratch. There was nothing done, so they had to design and build them. The team consisted of these three engineers. Two were from CMU, and they had electrical engineering degrees, so they built the boards. And I was the one software person, and I was responsible for doing the code. So the first thing we worked on was the communication lines. It was called the DDL 601A, for what that's worth. DDL stood for Digital Data Link. There were identical boxes, one in the tower and one out by the wayside equipment. And they would talk to each other, and the box in the field would receive the commands from the office and then distribute them to each of the signals and the relays, and the track switches.
Sure.
In the office, once that was done, we made the what was called then the System 700. And that was consisting of three different computers. One that controlled the display and the keyboard, and that also did the logic. One did the communications, and the other one was responsible for lighting the lights on the control panel. And the first customer was the Southern Pacific Railroad in Colton, California. And that would have been in, let me see, it was probably 1981. I think that's
pretty late.
Yeah. It took a number of years for us to get this project off the ground. So let's see.
So until then, which is really not long ago, the railroad operated in this very rudimentary.
Well, yes.
Now, but at that time, I guess that's all we had.
But it was very complicated because it was the very complicated relay systems that were designed to allow people to do stuff that was wrong, that couldn't be done on the tracks, but it would stop it from happening because the command wouldn't go through because of relays. In the computer, you would do it much more easily. So, but the relays were very complicated wiring systems to
Uh-huh.
do this by wiring.
But in the computer era, I'm assuming that fewer mistakes
Yes,
were, yeah,
absolutely.
yeah.
But a computer can also fail.
That's another question.
The fail-safe components were all in the field. That's why we didn't touch them at the beginning, because they could fail
Mhm.
and it wouldn't hurt anything. Nothing would go wrong. They were called vital relays because they were always known to fail in known ways. They would fail by opening the
see.
contacts and never closing them by accident. So,
What does that mean?
well, if you close a contact, electrical flows through it, and that could move a switch under a train
Oh,
on top of it.
I see, closing it opens it.
Open the switch.
Okay.
Anytime it failed, the controls were always open. So that would mean that
I
a
see.
switch wouldn't move or a signal would go red.
Okay, so it's sort of, that, to me, that's sort of counterintuitive.
Right,
Yeah,
right.
closed means open.
Yes.
Yeah, okay,
So
amazing.
once that system was installed and running, and it was all programmed in assembly language, the next thing they wanted to do leading up to the relay stuff, they had a whole bunch of relay engineers at that time, and they didn't want to have to train them in software. Because, the machine language that you had to use for microprocessor back then was very complicated.
Sure, yeah.
So I came up with a language where you would allow them to use their existing skills in ways that would program the microprocessor. I have an example here that shows how a gate crossing, a
Okay.
street crossing rails would go. And the Genesis system, which is the one that this is designed for, the system had both input boards, inputs from the track, and output boards to the various devices. If you think of a grade crossing, there's the arms that have to come down. That would be an
Yes.
output. You would say arm down. Their track input from when there's a train there, there's a train.
Sure.
So the inputs would be the east track, the west track of the thing, and the outputs would be the bells and the gates. And then there's the logic down here that determines when a train comes, what to do by setting the outputs. So to control the entire railroad grade crossing, it takes less than a page of code. So that's much more simple than trying to program a computer in assembly language.
I see. How long did it take you to do all of this? It's remarkable, it's unbelievable.
I think it was probably a 4-year project.
4 years.
About 4 years.
Did you enjoy that?
Oh, Lord, yes.
You loved it?
It
That
was-
was right up your alley too, so to speak.
Well, the engineers that were assigned to this job were all about the same age, and we loved working with each other. We had great fun doing it, and at the end of the day, we created the system.
Yes, unbelievable, fabulous. Do you have any idea, we haven't talked about this before, but I'm just curious, what did it cost for that to happen?
Oh,
The
Lord.
railroad, do you think, what did it cost the country or the railroad for that to happen?
I wasn't in any way involved with the finances. But
Okay.
if you imagine, we probably, there were the 3 prime engineers, and we had a support staff of maybe 5 or 6 more over a course of 4 years.
Yeah, okay, so you can sort of figure that
Yeah,
out.
exactly.
And then was that system used for other railroads?
Yes.
Okay,
Well, the next step was to replace the vital fail-safe relays in the wayside equipment. The first,
Oh,
I
yeah,
already talked about.
yeah.
So that was the hard part. That would be the microlock side of that code.
which you're gonna show, we'll show that,
Right.
yeah.
And that required a lot of hardware engineering on the computer side because we had to be able to run tests to make sure the output didn't fail, the input didn't fail, all
Sure.
that kind of stuff has to go
Sure,
on.
sure.
So, but the good news was it was also a relay system. So my relay programming language was also appropriate for that. So we were able to program both the non-vital and the vital with the same relay code, or the same programming language.
Mhm. This is an odd question too, but we talked about this, but the leadership of that railroad, were they incredibly appreciative? Did they understand what you had done to really revolutionize?
Well, for
The
the
world.
railroads, the real big win was they didn't have to do a lot of maintenance. The computer didn't even have disk drives. It was just all solid state.
I see.
The program was burned into what we called EPROMs. They were electrical erasable. There was a little window on the top of the chip, and once you had programmed it, and suppose during testing you found it was wrong, you put it under a UV light and it would erase it. And you could program it
Oh
again.
my God,
That was instead of a disk drive.
amazing, amazing. So they did understand, they did appreciate, they did,
from the perspective of needing less maintenance and smaller space.
yeah.
So they were definitely on board from the beginning.
And safety and
And
everything,
absolutely,
yeah.
everything.
Incredible.
So that basically ended when this would have been 85, I suppose. The PC had been invented. I had done the programming language on the PC at that point, so that the engineers would use the PC to do the programming. And about that time, the value of the dollar went against us, the railroad company. It was very high. The dollar was worth a lot of money. And that meant they could buy foreign equipment for a whole lot less. Because the dollar was so high, it was cheap to buy foreign stuff. So I was ultimately laid off from Union Switch. I had left.
I see.
And the next job I had was at Dun & Bradstreet in New York City. And there I did similar things. It was network communication and telephone touch-tone input stuff. Back then it was relatively new to do that. And I won't go into that because it's sort of irrelevant. But I was there for about 5 years. And toward the end of that 5 years, I got a call from out of the blue at work asking if this is the Terry Davis who used to work at Union Switch and Signal. I'm like, and yeah, I am. Who is? Well, I forget his name. I'm from General Railway Signal in Rochester, New York. Yeah, I had known about them. They were our prime competitor.
Okay.
And as I say, they were in Rochester. And I immediately said, well, I'm not sure I want to live in Rochester. And his reply back to me was, well, I'm not sure that matters.
Oh my gosh. Woo.
And I was at that point intrigued and scratching my head.
Sure.
So he set up a meeting, actually it was several meetings over the next couple weeks, maybe a month, where they came to New York and I had dinner meetings with them, or I think one or two I went to Rochester and had some meetings. And then a few months later, in May, that was in May of 1990.
Okay.
And it wasn't until October that they first mentioned going to China. So it was a long time they were talking to me before they finally had me set up to go to China. So it was in, I think, November that they allowed me, they actually paid for me to go to China to look around and see what I thought of the place. And then by June, it was June, that they sent me to Middlebury College to learn to speak Chinese, at least a little bit. 9 weeks, 8 hours a day, trying to learn Chinese. It was quite a time.
I can't imagine learning to speak Chinese and learning and knowing this quote language that you're talking about two very different
very,
difficult
very
languages.
Different.
Yeah.
Very, very different.
Amazing.
My job there wasn't so much technical as well. I was managing people. I was hired as a manager of software, and that meant there were lots of problems that happened. One, which was definitely cultural in nature, was very unusual to me. There was an employee who got a job offer at Motorola in China. These were a group of young engineers.
Okay.
So working for Motorola would be more prestigious than working at Casco Signal Limited. Do you know what I'm saying?
Okay.
So the guy wanted to take the job. Well, in China, you can't just leave. Your current employer has to approve of your leaving. They essentially have a lock on you. Well, he decided he wasn't going to work. He was just going to sit there and do nothing.
Oh.
You don't want to let me go? Well, then I'm not working. My task became to sit him down and try to convince him to work.
Oh my gosh.
I'll bet they had me do this over the course of several weeks. I tried to convince him I could do nothing, but my task until it worked was to convince him to work. Well, that never worked, believe me.
Never heard of such a thing.
It was
Never heard of such a
it was totally
fascinating.
crazy. But that was China in those days. The other thing I sort of took away from that Chinese experience was that there was a park in Shanghai. They had memorialized a sign from the past, from when the British were in control, that said, at the entrance to the park, no dogs or Chinese allowed. Can you imagine?
And where was this?
At the entrance to a park in Shanghai.
Oh my gosh.
And this is Shanghai.
Yeah.
But now, mind you, at that time it was 91 and it was no longer the rule.
Yeah.
But they were showing how they're.
How that was, what had happened.
Right,
Yeah.
right.
So you were going into a very, very different environment when you went there
Absolutely.
with all these different languages.
Well,
Unbelievable.
an example of what they were paying these engineers, it was the equivalent of $14 US a month.
How can that be? How could you?
It was China
that
in those
time?
years. $14. Now
A month?
they also got living space in a dormitory.
Oh my gosh,
See, and that was an engineer.
amazing.
In
How
China.
long were you there?
I think it was about 6 months.
Oh, just
Oh.
6. Oh, okay.
It was, but the what am I thinking? The president and there were a president and the software manager were U.S. people. The Casco Signal Limited were the joint venture between the Chinese and the Americans.
I see.
And the Americans were these two positions, the president and the manager of software.
Yeah.
And both the president and I went to Middlebury. And while we were at Middlebury is when the president told me, it had just happened, that the Chinese government gave them all the money for the project they were currently working on, and it was up to them to manage it and
I
keep it
see.
safe. Well, the CFO, who was a Chinese national, played the foreign exchange market and lost most of it. So we went into a situation that was not very good.
No,
It's
no
not very
kidding. I'm glad you're back.
good. Yeah, so
I'm very
am I.
glad you're back.
So
I'm very
am I.
glad you're at Wheels Museum.
So am I.
Oh God, and you're wonderful at Wheels Museum. Tell us, what else do you want to talk?
Well, Wheels Museum.
Yeah,
Let's talk
so
about wheels.
You're so wonderful here. You wait on all the customers. You run the train. You are able to describe so many things
Well,
about.
my
railroad.
favorite part is welcoming you here, opening the door,
So
and,
fun.
and just seeing. Have you ever been here before? Most of them say no.
Most of them say no, and yet some come every week. So yeah, it's wonderful.
There's definitely a mix for sure.
Yeah, yeah.
And I definitely enjoy giving smiles to kids by driving the train.
Oh, everyone loves you here, and we're so grateful to you. It's wonderful, and,
Well,
and I'm
very
so
happy to be
happy
here.
to have this history. And we're going to show the viewers an exhibit that you made about your work, and it's
Great.
very, very important to us. We're so thankful to you for coming and helping us with this
Well,
today.
I'm glad to be here. Thank
Thank you so much. Wonderful. Was that good?